to make this video today to talk specifically about which programming language that you should utilize and learn if you're coming up as a brand new developer, you don't know anything at all, you have these three languages, these three choices, you know these are the three big kind of like primary languages that are used throughout industry currently. So like, which one do you choose? Do you choose Python, C++, or Rust? And so within that upfront overall, to me, the best piece of advice that I can give you without going into anything else is what type of work environment do you want to look for overall? And I think that will give you kind of the best guiding light that you could possibly look for with regards towards this. So very specifically, if you're looking for more startup culture, more organizations that are looking to move fast, break stuff, Python is the way to go. That's organizations that will be utilizing Python. If you're looking for very established industries, very lots of work, a career that will never go away, 100%, you are guaranteed work forever, into your old age, for the rest of your life, C++. If you are looking for the career advancement and button up and security, and you want to get into like dev security and DevSec and like all of those types of things really interest you more than any other area, Rust is where I would go. And that's kind of what I would use as my overall determinant within this. But so let's dive deeper into these three languages and suss out the differences, give you kind of more in-depth breakdown of these three. So starting off with the language type. Very specifically, Python is different than any other programming language in that it's an interpreted language, meaning that with every other language, in this instance C++ and Rust, they're both compiled languages, meaning that you run your code and then it gets compiled into machine language, and then that compilation happens before the execution happens. So you run your code is compiled, and then execution happens. Whereas with Python, it gets interpreted into machine code. So rather than compiled into machine code, it's translated, and it's translated like in real time, like back and forth. And then so the benefit of that is extreme flexibility, and the drawback of that is extreme resource usage. And then we'll get deeper into that. So with the primary use cases for each language, with Python, you see here web development, data science, and automation. Data science is the biggest one overall, and data science meaning more so with regards towards like neural networks, especially if you want to get into anything with regards towards like LLM models, anything like that. All of NVIDIA, what NVIDIA builds out as far as their libraries, so like PyTorch, anything along those lines, like NumPy, all of these huge machine learning libraries, they're all built in Python, which is why like Python and machine learning go really hand in hand as far as that. Like honestly, it's NVIDIA that drives the huge like kind of interest and thriving community of Python and the interconnectedness of Python and machine learning. There's also a huge kind of like backlash movement against that within the C++ community. So there's active amounts, like anything that is in Python is also in C++, right? That's like you'll know that's a big thing that you'll notice is like especially for machine learning, because it's not wanting to be left out, but it can be more difficult overall. And we'll dive deeper into this again as we get more into this. But so with the primary use cases of C++, it's more so for systems programming, really for game development, and then embedded systems, because these are and then with Rust, it's a biggest primary use cases are for system programming, safety critical applications, and performance critical applications. Everything that is critical, reliant on safety, etc. And you'll notice that's a big thing without Rust, and that's why Rust is proposed, like why Rust gets so much traction overall as opposed to C++, because C++ has been around forever, right? C++ has security vulnerabilities, flat out. Like, it's not secure, and there's aspects of it that are very not secure. We're going to get into that starting with this very next subject as far as memory management, right? But so before we get into that, into memory management, why does this security of these two languages, very specifically C++ and Rust, matter, right? And that's because C++ is listed here as a mid-level language, and Rust is listed as a system-level language. But both C++ and Rust are system-level languages. It's just that in more and more use cases and more organizations, they don't want C++ as the system-level language because of the fact that it can have so many system vulnerabilities, right? And then so that's why Rust comes about, and why Rust, again, is huge. It's because of that search for a more secure system level coding operating, a more system level coding language. And then so diving into our next subject, which is memory management. With Python, it's automatic memory management, and then so essentially you have a garbage collector that goes through, and then as it's interpreting, it automatically deals with any sort of memory issues. With C++, it's a manual process. So with both Python and C++, you can run into vulnerabilities. You can do very bad things with the memory management. You can create forever for loops, lots of different things, right? Like, there's lots of different errors that you can run into with memory management. Whereas with Rust, it uses this ownership system, which increases the complexity of understanding and the system overall. But the trade-off for that is it's impossible to run into major critical memory issues with Rust. and when you're dealing with systems level applications, it's very important, right? Like, if you don't want memory leaks of your system level applications, which is a very big problem with C++. So in terms of performance, flat out, Python's going to perform worse overall. Like, no matter what you do, any scenario within this, and it goes back to that interpreted versus compiled, right? And compiled is always just going to be faster, like light years faster, light years, much more much less resource heavy overall. And then with performance, and the big thing is with C++, you get near hardware level performance, right? You're not going to get better performance than C++ overall, and it's been min-maxed, right? Because C++ has been around so long. Whereas with Rust is going to get you near C++ performance, but generally speaking, in most applications right now, the C++ variant is going to outperform. Like, it'll be the best performing variant possible. Will still be in C++ as opposed to Rust, but with Python not even in the consideration. So if you're talking about if performance is at all an issue for you, like 1% a consideration, then you automatically are ruling Python out from this discussion up front. Concurrency is a big issue, and this is tied to performance, but concurrency is its own thing related to performance, right? Concurrency meaning multi-threading with regard to the CPU, so multiple applications running at the same time. So within Python specifically, you have multi-threading limits. You can get around this, and it does support multiprocessing, but it's you're more so simulating multiprocessing within Python, right? And so that goes into this those performance issues. So the interpretation as well as multi-threading issues are big performance issues within Python. Whereas with C++, it's multi-threading is native to C++, but you do have to do manual synchronization and configuration. So when it comes to multi-threading in C++, it's easy to do it wrong and to run into lots of errors. Whereas with Rust, if you're implementing multi-threading, it's impossible for it to compile and for it to compile wrong, like, or for errors to happen and for any sort of concurrency issues to occur, because you'll know before it compiles. With regards towards safety, Python is going to be the least safe overall, flat out. You have runtime errors are really common. All types of issues can occur because it's interpreting, right? That real-time interpretation, just all sorts of issues. The big issue with safety and C++ is regards towards manual memory management. With anything that you're doing with regarding towards memory with C++, you're setting the memory, which is great with regards towards flexibility. So if you want like that same sort of flexibility, jump in like Python, be able to do anything that you want with it, with more structure kind of, then C++ gives you that still, right? And then Rust kind of just takes that all away, just flat out on it. Like, it's all built like 100% built around safety. And then so we get into learning curve. So flat out, like, Python is designed to trick you. It's the easiest language to get into and to learn. Like, if you have no experience whatsoever ever looking at code, and then it makes your head hurt just to look at code and syntax and everything like that, Python is designed to take care of a lot of those issues for you. And then so that's really where it comes in there as far as learning curve. C++ is a higher learning curve, it's a lot more strict as far as syntax, and there's a lot of things that you can do wrong, right? Like it's a very high learning curve in that instance, just because the language has been around for so long. There's so much of it that you don't use, so many libraries that are just worthless, right? And that's like diving through that. So you can do things really wrong within C++ really easily. Whereas with Rust, it takes all of that away, but it introduces this concept of ownership and borrowing, and ownership and borrowing is how it very specifically deals with memory management. And then this ownership and then checking out and borrowing system is what 100% eliminates any sort of memory issues within Rust, but it's a whole subsystem that you have to understand and learn in order to utilize that within Rust. And then so with regards towards compilation. So again, when it comes to Python, Python is interpreted language. So there's no compiling happening, right? It's interpreted. Like, think of it as the computer is speaking French, and then it needs to get into German, and then there's a translator back and forth. And then so you speak French in, and then it spits out German, and then the computer goes, okay. Whereas with C++, it's compiled to machine code, and then there's several different packages that you can use to do your compilation, right? And then so that's, again, what goes into the complexity of C++, is that because it's been around for so long, there's so many different packages and variants available. Whereas with Rust, it's, again, compiled to machine code, but it's rusty, and you're always using cargo, right? Like, you'll get used to, like, if you decide on Rust, cargo is what you'll use, and anything for compilation will always be cargo, and that's just how it is, right? And it's a very simplified in that instance. Diving into these specifically, when it comes to error handling, what we can see is within Python and C++ and Rust, there's different methods and different ways to capture exceptions. And then the big thing to note within Rust is that Rust doesn't utilize exceptions. It uses result and option types for error handling. So when it comes to error handling specifically, I would say that just as a general user, this is a part of what goes into the user friendliness. Python is going to give you're going to know exactly where your error is, because it's going to error exactly where the error is within the interpretation, right? C++, it's going to error before it compiles, which is going to be a lot more frustrating if you're dealing with like a huge amount of code, and then going through exactly why it's erroring, and then you can deal with like multiple dependencies and multiple dependency issues and hierarchy issues and things like that. Whereas with Rust, you don't deal with those same hierarchy issues, but you can deal with like Rust is a lot harder to deal with regards towards error handling, with knowing like exactly where the error is and why it's erroring until you learn the error outputs. And then once you learn it, it's easier to me overall, but it's a higher learning curve up front. Syntax style. So syntax, again, it goes into the user curve and that early learning curve. Python is built all around being just simple syntax, right? And we'll get into that if you look below at the hello world, just how easy it is, right? And that's the beauty and simplicity of Python overall. Exact opposite with C++, right? Like it's like syntax YOLO, whereas Rust is you're kind of like, it's a middle ground where it's like it's more built off of C++. So if you're familiar with C++, it's good for you and designed for that, but it's also designed to be like simpler and more user-friendly like Python. So it's kind of a blend of both of those. Within tooling, I would say overall you have access to the easiest amount of tools within Python, right? Because Python, it's your big tools are interpreter, pip, virtual environments, and Jupyter notebooks. And then Jupyter notebooks, you can run like Google Colab, all types of things. Make it really easy to just for anyone to be able to run Python, compile Python, like in the cloud, on your computer, wherever you want. C++, they have a lot of compiler options, and then so it's almost as easy, but like not quite as easy as Python. And then Rust is a lot like you are just more limited as far as options. Again, so you can see here cargo, right? And everything is tied to cargo, but you just are more limited as far as your options as opposed to C++. But generally speaking, it's the same options that you'll find with your C++ compilers and tooling systems. With community, the Python community is very large, it's very diverse, and then it's like across the board, right? Lots of beginners, lots of experts. C++ is large, industry focused, like more exclusive overall, and then whereas Rust is very small, it's a lot of learning and doing things on your own, but like also like a lot more inclusive, right? like willing to take you in and teach you if you're running into issues there and want to get into it overall. Moving on to the notable features within Python. So you have dynamic typing and extensive standard libraries, meaning that like pretty much anything that you want. It's very easy to create libraries within Python, and then so libraries making it just really easy to just run a line of code and then do lots of things. Right? It's that's exactly how Python is built around that. Whereas with C++, its major feature is manual memory control, template, and meta programming. So manual and memory control is both the biggest plus and biggest minus of C++ overall. It gives you the most flexibility, and it's the thing that like business owners and like the top end of the corporation hates the most. It's the thing that like, the developer will like the most as far as freedom once you like dive into it, but it's again like not the most longevity. So then with Rust, its notable features are it's just 1,000,000% built around safety, like from the ground up around all of the safety issues that C++ has. Rust is designed literally to tackle like each one of them, like row by row, right? And then as far as common frameworks, I'll just rather than read them off, you can look at them here. These are just common frameworks that you utilize overall for Python. They're web frameworks and machine learning. For C++, it's more geared towards game development. And then Whereas with Rust, Actix, and Tonic, like, these are more geared towards like productivity. And then so typical hello world, you can see here, very straightforward again with print hello world, right? Very straightforward with Python. And then you can see, again, the most complex one is C++, and then your middle ground or your blend there is the Rust, right? Like it's familiar if you're used to C++, but giving you kind of that more simplistic approach of Python. So going back to the initial question, which one would I go towards and lean into if I'm very first starting out? And again, it's whatever you're looking for most overall. If you're looking for like that like startup culture that is going to like care more about like doing things more than anything else, it's Python. If you want a lot of support, your job's not going to go anywhere, C++. If you want like what businesses want the most and what will probably be more and more growing, like you're willing to take a little bit of a risk on that, like the more growing community, but with reason, is Rust. And then so overall, if you like this type of content, please like and subscribe. Thank you very much.